So hello everyone again. My name is Marko Blašković, and along with Kristina, Klemenčić, Novinc, I will give you today's weather briefing. I will actually talk a bit about yesterday's weather, while Kristina will then, in the continuation, talk about the weather today. So we can start, and as usual, I will give you a moment or two to pick your annotation tools, the pointers or some crosses or highlighters. Please take some of them and please mark where are you listening from. Of course, if there are people from other parts of the world, not only from Europe, please either tick a continent on the left side, or you can also write the place you're listening from as well. Okay, I see we have mostly people from Central, Southern Europe, some from the western parts, northwestern, Lithuania, Denmark, Italy. Okay, I assume more people are still coming, so we will not hold too long on this slide. But anyway, thank you. Yes, thank you for annotating. So let's. Oh yeah, somebody from Africa as well. Thank you for annotating. We will move forward then, and then let's start with a simple. Let's start simple with a short task for you. So on this infrared 10.8 micrometer channel, which I looked at yesterday in the morning as well, I was asking myself, where can the border between the air masses, for example, polar subtropical air mass, be, and where can the low centers on this image be? So I'm asking you the same questions. Please use your annotation. Try drawing a border between the polar and subtropical air mass, and if you can, please locate some of the jets. No, I'm sorry, not the jets, the low centers on this map. I'll give you half a minute for that, and then we'll move on. You can either, yes, use the highlighters to write letter L, or you can type in letter L with the little text tool that you have up there in the annotation tools. Okay, yeah, I see some, yes, great. See some obvious ones, and yeah, you made good work. Unfortunately, only one of you has drawn the border between the air masses, but it doesn't matter. We'll see the result, actually the solution, in a slide. So if we go forward, we can see the solution for the first question, the border between the two air masses. If we check now here on this temperature field, for example, the 2 degrees isotherm, we can see that the border oscillates really nicely across the continent. Basically, we can identify, let's say, the Rossby waves from that, and let's go a bit forward. And here on this slide, we can see, for example, the lows that you have shown us in the slides before. Here, there is still no low. There was no low yesterday, but a low, I believe, developed during yesterday and today because of the effect of the Alps. Here we also have a low. It was not very obvious because it was in the cold air and the fronts are not very developed, and actually this cyclone form is not very developed because it is in the cold air. And here actually we have, well, almost two lows. There is also one low on to the east over Russia, but that one is not that important for us. And this low here over eastern parts of Europe, which is slowly filling up. So some kind of frontal characteristics of the cyclone that has existed here are basically gone. Okay, let's go forward. Another task for you: please take a number in front of these conceptual models. Again, you can either write them in the map, either with your highlighter, or you can use the text tool from the annotation tools and write where you think these conceptual models can be found on this infrared image. I'll give you a moment or two for that, and then we'll continue on. One hint for the fourth conceptual model of transverse bands, they're rather small scale features. So if you cannot find them, it doesn't matter. We will come to them later, but anyway, if you know where to look at, you will know approximately where to see them. But anyway, we'll come to them very shortly. Okay, thank you. Actually, I see many numbers, many conceptual models all over the place. And yeah, thank you to all. We will continue forward to just assess the situation and see. So this is the air mass image from yesterday morning as well, and these are the models that I have put in. Of course, there are more models on this image than there are actually here noted. I did not note all of them. Some of them I maybe missed. Some of them were not very interesting to me, maybe. But anyway, we'll go from left to right and shortly analyze all of them that you see here. So, So from the left side, the cold front that you have noted, yes, well, I have put the cold front as well here, but with a little asterisk up there because it is not very usual, let's say. The cloudiness of the cold front is very weak, and this is basically because the post-tropical cyclone Epsilon is still, I would say, at least it was yesterday, in its transition phase from a hurricane into an extratropical cyclone. So let's say the fronts were still not very visible or obvious, at least to me. I mean, maybe some of you are more experienced and could have seen them and recognized them at once, but that is why I put here an asterisk over the cold front, just to say that the cold front is still not the usual one we are used to see, with many clouds in it, like, for example, this one that you have all very nicely identified. And the reasoning, well, yes, as I said, this is, I believe, still some kind of a transition phase between the hurricane and the next tropical cyclone. But of course, as the cyclone is progressing to the northwest, it is still sucking in the warm and moist air from the south, and by its rotation, it is bringing cold, very cold air from the north, and they are the two different air masses are basically colliding somewhere here, and I expect in the next couple of hours, half a day, even today, since this is an image from yesterday, that a stronger front than these couple cirrus clouds will develop and be a bit more visible. Again, the cold front by itself is very, very strong. Seen here in the vertical cross section, the cold direction is very, very strong. But as I said, there are no high clouds. You can see that this is really dry in the upper levels, but there are low clouds, which can also be seen here in this pinkish tones on this 24-hour microphysics. Okay, just shortly about Epsilon, since we've started this topic, the hurricane, the Epsilon, actually developed over the western coast of the US. It soon increased into a level 3 hurricane, which was on, I think, the 21st of October, but then it started slowly drifting off to the northwest, and it started its transition from a hurricane into an extratropical cyclone. And this is, yes, as I said a couple of times, this is that phase, I believe, still. And of course, the question was for me yesterday morning when I was looking at this, will it hit something, will it hit some significant land mass, a country or something? And as it seems from the hurricane center, it looked like it will weaken before it will hit something significant like Iceland or Ireland. So as you can see here on this image, the 50 knot, the probability of a 50 knot wind sustained during 1 minute will diminish to basically nothing over the next couple of days. Actually, from yesterday and in the next couple of days. So there should not be any big danger for either Ireland or Iceland. And here you can see the trajectory of the now cyclone Epsilon during yesterday. Okay, so let's shortly continue with these conceptual models that we have started with. So the upper level lows, I cannot remember if you have put some of upper level lows on the task slide, but anyway, one upper level low is here. The transverse bands are actually an important type of cloud formation that are associated with high vertical wind shear and are usually found in the vicinities or actually across a jet stream. So because of the high gradients of wind speed, the wind shear is strong, the turbulence is strong, and this is actually a quite important weather phenomenon, actually cloud formation, to be observed by the aviation. Intertropical convergence zone is here and a bit below this image. Another upper level low is here over the coast of Libya and over the Mediterranean. You can see how nicely it develops, actually creates the convection over the country and over the sea. The cold front, as you have nicely noted here, is one actually quite huge cold front going all the way from Scandinavia down to south of Spain. Another transverse band cloud formation here over this cold front because of the associated jet stream, which we will see in a moment or two. Again, occluded front with the asterisk. Basically, this I would just put here an occluded front because I thought this and this were a cloud, I'm sorry, a cold front and a warm front from basically dying cyclone, which passed this area, as I said already, during the weekend. And the cyclone is slowly filling up from below, so from the lower troposphere, but in the upper levels, an upper level low is still persisting. And actually these, let's say, cold front and warm front formations will basically disappear in the next couple of hours, half a day maybe, while this cloud structure and actually upper level low that sustains the convection will still be here during the day, and maybe even today. To be honest, I haven't checked if it still persists over the eastern parts of Europe, this upper level low, but during yesterday it still did. The warm front here of this quite common cyclone is here, and actually the warm front still goes here. And this is actually not an occluded front, an occlusion front. And why it's not an occlusion front, we will come to that in a short while. So here you can see the streams. With that, you can also tell that they, for example, divide the polar front. Sorry, not the polar front, the polar cell, the Farrell cell, and, for example, the Hadley cell. As I was talking here for the transverse bands, you can see that the jet stream is very, very strong, and actually the gradients are also very dense. That is why the wind shear is very, very high, and the turbulence is also high. So the transverse bands as a cloud formation appears on this side of the cloudness of the front. Yes, as well, I wanted to point out with this water vapor image that you can see really nicely those upper level lows, for example. And now let's continue on. I put this meteor alarm sheet from yesterday morning as well, as you can see here. So not all alarms were issued at that time, but it was at my time of watching, so I wanted to put that in. I was mostly concerned about the wind that the cyclone will bring somewhere on this path. So I thought that maybe the Irish and the people in Iceland will put some alarms for wind for actually today. So this is a meteor alarm from yesterday for today. But there was no wind warnings, which I was, well, slightly surprised. But then during the day, actually, the colleagues from Iceland put a wind warning for today. There were some wind warnings for the western coast of France, for Spain, and as we saw the big cold front crossing the continent, some rain warnings, some thunderstorm warnings, even snow warnings in Austria and surrounding countries, which were, well, quite obvious at that point. Well, now at the end, I would just like to tell you why that wasn't in the north, why that wasn't a occlusion front, but rather a warm front, and actually the reason why that was a warm front. We can see now, if we pull a couple of vertical cross sections over the front, we can see, first of all, without pulling any vertical cross sections, that in the middle of, actually at the core of this cyclone, the air is warmer than the surrounding. That's the first thing that we have to note. Then if we pull this vertical cross-section, we can see that actually the front is not an occluded front as we would expect with the very nice V shape that is very usual for that, but rather a warm front inclined here and a warm core as we can see in the isotherms. As well here, just a bit farther from the previous place, we can see exactly the same thing, very nice warm front here in the vertical cross sections and a warm core as you can see it on this graph. If we pull down again a vertical cross section over the cold front very near to the warm front, we can see that the cold front is almost dissipating. The gradients are very low and the temperature is almost not changing. This is called a gap in the cold front this time. And if we check a little bit further down to the south, we can see that the cold front is very nice, very inclined very nicely, and that the temperature rises on the front side of the front. So basically, with all these things in mind, we conclude that this is actually a Shapiro-Kaiser cyclone, and that is why this occlusion isn't actually an occlusion, but actually a warm front with a warm core instead of a cold core that is usual for the Norwegian type. And at the end, just to show you how the weather changed from the morning of yesterday to the afternoon of yesterday, and that would be it actually for my part. And from here now for today's weather, we have Kristina. Kristina, hello, hello.
Hi everyone.
Hello.
You had a question. Somebody asked what was the white indicator?
Yeah, I will answer the questions after the presentation ends. So yes, please just keep the questions for the end. You can write them, of course, in the chat box. But anyway, yeah, thank you for your attention. And now it's Kristina's turn.
Okay. Hi everyone. I just have to tell you that at my work the internet connection is not really great. So if you cannot hear me at some point, I'll be back. So, since Marko gave us such a really nice introduction, you're already more or less familiar with the situation for today. Before we start looking at some interesting and maybe energetic situation for today's weather, first I would like you to take a look at the image and maybe point where you think there would be some slow weather with some fog and stratus clouds. Okay, very good. Nice. I really liked the picture because it was easy to notice where the fog is. I'm not sure if you can see all the synop, but what was interesting for me is that the fog is mostly situated here, while the low clouds are more to the east. So let me just clean it so you can take a look. And if you notice, if you take a look at the image that has a little bit better resolution, then you can see that the fog is mostly kind of pinkish, while the low clouds are more bluish. Okay, now when we looked at that, let's go back at 24-hour microphysical image. This one is from 6 UTC this morning when I started my presentation. So would you please try to put where you expect the jet streak and jet stream? Okay, thank you very much. So the really big low, the valley that's formed is kind of a dead giveaway, but the other areas were not so easy to see on 24-hour microphysical. So what we are going to do in the lesson is to take a look at the area that's most interesting for Croatia, and that's Mediterranean, mid-Mediterranean, and Adriatic Sea. So what we are going to look at is actually the cold front. And now, if you could put a star, do you expect this to be an ANA front or a Kata front? You can put a little star or asterisk or something next to the image. The images are also from 6UTC. It's a water vapor image on the left, and on the right you have infrared image. Don't be shy. For someone who's really familiar with images, it will be kind of easy to see it at the first glance, but it takes a little bit of sharpness and a lot of hours looking at the images. Okay, so all of you choose Kata. One ANA, okay. Okay, so I will not give you the answer yet, because we're going to look at some data. First, we're going to make a little insection and take a look at the cross-section and what's happening in the atmosphere. It's easy to see from the temperature advection that we have a cold front in a cold advection, while the warmer air is staying in the upper parts, connected with the warm belt that brings the warm air in the upper parts of the atmosphere, while the cold air is down low and going towards the east. Next, what we are going to look at is the omega, or vertical motion. We can see in the in front of the front we have quite lift, while at the back of the front we have submerging air. The sea is still quite warm. The temperature is between 19 and 21 degrees in the south and 17 to 19 degrees in the north part. So there can be some cape. What else we want to see, if there is maybe some convection, is the wind. The wind is quite strong in the lower parts. It's windy at the seaside. There is strong and stormy Yugo, southeast wind, and southwest wind. That's why there isn't much shear. So we wouldn't expect too much of convection. For me, the best way to see if it's a Kata or ANA cold front is actually to take a look at the frontal parameter, and also to take a look at the relative humidity. So first we take a look at the frontal parameter, and we can see that the front in the lower atmosphere is more to the back than to the middle of or the front of the clouds. And if we take a look at the relative humidity, we can see that most of the humidity is in the front of the frontal band, which then clearly indicates that we are working with Kata front. In fact, why I said it was easy for people who already looked at a lot of images, the water vapor and infrared images, is that it has quite pronounced clouds in front of the front. That's why it's always kind of whiter than at the back. So if you don't have enough time to take a look, and you usually don't when you are in a shift, you can take a look at the water vapor images and infrared, and it will be quite easy to distinguish, even though sometimes it can be tricky. Usually ANA fronts are found at the Atlantic, while Kata fronts are more connected to the systems that happen at the continent. So what would we expect when we have Kata front? Usually we expect most severe weather near the occlusion and at the, let's say, tail of the front, because here we usually have jet coming in and then intensifying the systems. So if we take a look at what happened, that's exactly how it happened. It's really a school case, so to say, of a Kata front. And most of convection happened here near the occlusion, just before occlusion. Occlusion is situated somewhere here. And here if you remember where you put the jet stream here, the jet stream kind of goes into the front and enhances the processes. So how it happened in Croatia, just forgot to show you. We are going to, so Opatija is somewhere here in Istria, while Senj is over here. So that's easier for you to understand about which cities I'm talking about. So Opatija had strong wind. There is no obstacle in front of it. There was strong southwest wind, not much here. So you can see that there wasn't much convection there. Also, you can easily see when the front has passed because there is a big drop in the temperature, same as in Senj. But in Senj, there was a bit different situation with the wind. Wind was quite slow in the lower parts of the atmosphere, so the shear was quite strong. That's why we had convection and about 13 liters of rain in about half an hour, while most of the rain fell in Malinska, that's island. It's usually near the occlusion on the cold front that we have the severest situations, and at the tail, because there is enhancement with the jet stream, the temperature dropped was quite strong, and the wind changed direction and strength after the passage of the front. So that's it. If you have any questions, I'll be happy to answer.